Today's lesson is on the quadratic formula. Let's start with some review. When you're asked to find the zeros of an equation, you are supposed to use factoring to do that. So let's review our factoring rules. We're supposed to first make sure this is in standard form. So we find our zeros by making sure that we have the x squared term first, then the x, then the constant, and that's all equal to 0. When we find the zeros, we make y equal to 0. We next identify our a, b, and c. A is 2, b is -1, that comes from the invisible 1 in front of the x, and c, which is our constant, is -6. We're looking for two numbers that multiply to be a times c, so that gives us -12. There's a variety of options here, 1 and 12, 2 and 6, 3 and 4, but to narrow that down, I need these to add to make -1. 1 and 12 won't do that, 2 and 6 won't do that, but some combination of 3 and 4 will. In order to make a -12, one of these needs to be a negative. In order to make the sum a negative, we need the larger number to be a negative there. We use those magic numbers to replace our b term. So we rewrite this as 2x squared minus 4x plus 3x minus 6. I replace the x term with the -4x and the positive 3x so that I can factor by grouping. The greatest common factor of 2x squared and 4x is 2x. 2x squared divided by 2x is x. -4x divided by 2x is -2. The greatest common factor of 3x and -6 is 3. 3x divided by 3 leaves us with x. -6 divided by 3 is -2. I know I've done this correctly because my two sets of parentheses match. That's my new common factor. I take it out, and that leaves me with 2x plus 3. Now, in order to find the zeros, remember this is all equal to 0. This has been equal to 0 all along. We just don't have to keep writing that over and over. We use our zero product property and set each one of these equal to 0. X minus 2 equals 0. 2x plus 3 equals 0. Add 2 to both sides to solve, and so x equals 2. Subtract 3 from both sides, so 2x equals -3. Divide both sides by 2, and x equals -3/2. So my zeros, or my x-intercepts on this, are 2 and -3/2. Let's try another one. If I need to find the zeros, I make sure this is in standard form, the x squared term first, then the x, then the constant, and set it equal to 0. I identify my a, my b, and my c. A is 1, that comes from the x squared term. B is -3, and c is 1. I'm looking for two numbers that multiply to be a times c. 1 times 1 is 1, and I need those to add to be -3. Well, the only thing that multiplies to be 1 is 1 and 1. 1 plus 1 can't be -3. Let's try it with negative ones. -1 times -1 is +1, but -1 plus -1 is -2, not -3. This cannot be factored. Cannot be factored. That doesn't mean there's no solution. We just have to use a different method. When a quadratic equation can't be factored, we need to use something that we're going to call the quadratic formula to find our zeros. To use the quadratic formula, we start these exactly the same way we would if we were going to factor. Our equation has to be in standard form. Ax squared plus bx plus c is equal to 0. We still identify our a, b, and c terms before we start. Then we try factoring, and if it doesn't work, now we can substitute a, b, and c into what we call the quadratic formula. So there's a -b in front of the thing, in front of the b there. That's telling you to change the sign of the b term. This is called plus or minus. We're actually going to do both on these problems. We're going to both add and subtract. That's what's going to create our two separate zeros. Then we find our square root, the square root of b squared plus -4ac. And once we do all that, we divide by 2a. So let's go back to our previous example. Let's first make sure that this is in standard form. We have the x squared term first, then the x term, then the constant, and we set that equal to 0. We still identify our a, our b, and our c. A is 1, b is -3, and c is 1. We already tried to factor this and it didn't work. There is no number that multiplies to be 1 and adds to be -3. So we need to substitute this into our quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared plus negative 4 times a times c, all divided by 2 times a. This tells you exactly where to substitute in, and so watch carefully. I'm going to leave myself some blanks. This is going to be negative b plus or minus the square root of b squared plus negative 4 times a times c, all divided by 2 times a. So negative b is negative negative 3. Negative negative 3 becomes positive 3. B, again, is negative 3, so we substitute that in. A is 1, C is 1, A is 1. Now we simplify. We've already changed our negative negative 3 into a positive 3. Let's next simplify inside the square root piece by piece. We always do our exponents first, so negative 3 squared is negative 3 times negative 3, which is positive 9. Be careful about your signs there. And then that's plus negative 4 times 1 is negative 4. And that's all divided by 2 times 1, which is 2. Again, we continue trying to simplify inside the radical, inside the square root. 9 plus negative 4 is 5, and that's all divided by 2. Now, 5 is not a perfect square, which means we get out our calculator, we find the square root button. Some of you are going to have to hit the shift or the second button. And the square root of 5, if I round that off to the nearest tenth, is 3 plus or minus the square root of we take the square root off, sorry about that. That becomes 3 plus or minus the square root of 5, which is 2.2 divided by 2. Well, remember how when we found the zeros, we split those up into two problems to use the zero product property? We also split this up into two problems. The plus or minus here means that we do both. We both add 3 plus 2.2 and divide by 2, and we subtract 3 minus 2.2 divided by 2. Normally we would divide before we add, but this big fraction bar, remember, works like a grouping symbol. That's telling you to add first, so this becomes 5.2 divided by 2. 5.2 divided by 2 becomes 2.6. And 3 minus 2.2, I hit enter, I get 0.8 divided by 2, which becomes 0.4. So my two zeros are 2.6 and 0.4. Remember, those are our x-intercepts. Zeros, otherwise known as x-intercepts, don't have to be whole numbers. In this case, we rounded to the nearest tenth. Let's make sure we understand what their position on the graph would look like. We got 2.5, actually that should have been 2.6. Let me make that adjustment there, sorry about that. We got 2.6 and 0.4. 2.6 is about halfway in between 2 and 3, so we put a dot there. And 0.4, which we got from our second answer there, 0.4 is in between 0 and 1. And so what that means is my parabola maybe looks something like this, or it could go the other way. Maybe it looks something like this. Okay, it cuts through those x-intercepts in some way. We're going to learn more about graphing later on. The square root portion of our quadratic formula is called the discriminant. That's square root of b squared plus negative 4 times a times c. It can give us some insight into how many solutions our equation has and what that parabola should look like. So a positive inside the square root, a positive inside the square root. So you simplify your discriminant and you get a positive number on the inside. That tells you that there are two solutions to the equation, which means there are two zeros. We just did one like that. We had 0.4 and 2.6 as our zeros, and so the parabola would look something like that in some way. Again, that's just a quick estimate or a sketch. We'll learn more about graphing completely later on. Now, if we get a negative inside the square root, we simplify this whole thing and we end up with a negative number. That means there's no solution to our equation, which means there's no zeros. That creates what we call a floating parabola. It is above or below the x-intercepts in some way. It might look like this, or it might look like this. It doesn't mean there's no graph at all. It just means it doesn't cross the x-axis in any way. Or we might get a 0 inside the square root. That means we only have one solution to the equation, which means we have one 0, which means the vertex falls right on that x-axis in some way. Maybe it looks like this, or maybe it looks like this. So let's review. A positive inside the square root, a positive for the discriminant, means that we end up with two solutions to the equation. A negative inside the square root means we end up with no solution to the equation, which means there's no x-intercepts. A 0 inside the square root means there's only one solution to the equation, which means there's one 0 or one x-intercept. So let's find our zeros here. X squared minus 5x plus 7 becomes equal to 0. This might be factorable, I don't know, but we're going to try it using the quadratic formula. So a is equal to 1, the invisible number in front of the x squared, b is negative 5, and c is 7. So this becomes negative b plus or minus the square root of b squared plus negative 4 times a times c all over 2 times a. So let's practice substituting in. Watch carefully. This becomes negative 5 plus or minus the square root. Remember, there was a negative here and a negative here. That's where the two negatives came from. And then as I substitute in, I go ahead and square this, and then that saves me a step. Negative 5 squared is negative 5 times negative 5, so that's 25, plus negative 4 times a times c all over 2 times a. We're going to continue simplifying. A negative 5 becomes a positive 5, plus or minus the square root of 25 plus negative 4 times 1 times 7 is negative 28, all over 2 times 1, which is 2. We're going to continue simplifying, so that's 5 plus or minus the square root of 25 plus negative 28, which becomes negative 3. So my discriminant, let's take a look at it. There is a negative inside the square root there. That means there is no solution. I cannot find the square root of a negative number. If I put that into my calculator, it will give me no solution there. So what I have to do is think about what this means for my x-intercepts. There's no solution to the equation. That means there's no zeros, which means there's no x-intercepts in some way. What that means is my curve maybe looks something like this or something like this. We don't know for sure where it is right now. You don't have enough information to be able to graph more than that because we don't have any zeros. That doesn't mean the graph doesn't exist. It just means we don't know where it crosses the x-axis because it doesn't. Let's try another one. Put it in standard form. X squared minus 6x plus 9 equals 0. A is equal to 1. B is equal to negative 6. And C is equal to 9. This becomes negative b plus or minus the square root of b squared plus negative 4 times a times c all over 2 times a. Watch carefully as I substitute in. That becomes negative 6 plus or minus the square root. B squared, negative 6 times negative 6 is positive 36 plus negative 4 times a times c all over 2 times a. We're going to continue simplifying. A negative 6 becomes a positive 6 plus or minus the square root of 36 plus negative 4 times 1 times negative 9 is negative 36 all over 2 times a, which is 2. This becomes 6 plus or minus the square root of 0 all over 2. So if I get a 0 there, that means there's only one x-intercept. I can keep going and simplify this. The square root of 0 is just 0. So that's 6 plus or minus 0 divided by 2. Well, adding 0 or subtracting 0 is just going to become 6. It's not going to change that number at all. So my x-intercept is 3 here. So that might look like this. It might look something like this. We're not sure, but it only has one x-intercept. We'll learn more about graphing later on. Let's try one more. Put this in standard form. 2x squared minus 10x plus 3 is equal to 0. A is equal to 2, B is equal to negative 10, and C is equal to 3. This becomes negative 10 plus or minus the square root of B squared. Negative 10 times negative 10 is 100, plus negative 4 times A times C all over 2 times A. You won't always have a 1 on the bottom of your expression here. A negative 10 becomes a positive 10, plus or minus the square root. We already squared negative 10 squared becomes 100, plus negative 4 times 2 is negative 8. Negative 8 times 3 is negative 24. divided by 4. We're going to continue simplifying. 10 plus or minus 100 plus negative 24 becomes 76, all divided by 4. I'm going to find the square root of 76. I use my square root button, and I get 8.7 if I round to the nearest tenth. So this becomes 10 plus or minus 8.7 divided by 4. This is going to actually give me two solutions because there was a positive under the square root. So I'm going to go ahead and split it up into two problems, 10 plus 8.7 divided by 4, and 10 minus 8.7 divided by 4. 10 plus 8.7, I hit enter, I get 18.7. Remember the big fraction bar is like a grouping symbol. It tells you to add everything on top first. 18.7 divided by 4 becomes 4.675. I'm going to round that off to the nearest tenth, so that's 4.7. For this one, 10 minus 8.7 is 1.3. 1.3 divided by 4 becomes 0.325. Rounded to the nearest tenth is 0.3. That means I have two x-intercepts, one at 0.3, which is in between 0 and 1, and one at 4.7, which is in between 4 and 5. That means my curve maybe looks something like this, or it could go the other way. We're not sure. We're going to learn more about graphing later on. So our summary today. To solve a quadratic equation that can't be factored, we want to make sure we put that equation into standard form. We want to be able to identify a, b, and c, and you want to substitute into your quadratic formula and solve. You don't have to memorize your quadratic formula, you just need to be able to use it. Thanks, guys. Have a great day.